Are we alone in the universe? We Earthlings have seen no credible signs that there are beings elsewhere in the universe that match us in smarts. Yet are there Paleontologist Peter Ward, co-author of Rare Earth, Why Complex Life is Uncommon in the Universe, points to evidence that intelligent life must be exceedingly rare. Other scientists, however, think that advanced life is common. Carl Sagan estimated 1 million intelligent civilizations in our galaxy alone. So Noah asked astrophysicist Neil deGrasse Tyson to play devil's advocate in a conversation with Ward. Time is of the essence. Neil deGrasse Tyson. Peter, when you combine the fossil record on Earth with all that we knew of biology and evolution, what can we expect as we look for intelligence elsewhere in the cosmos? Peter Ward says there are maybe 30 million species on the planet today, 10 to 30 million. If you look at the fossils, there are hundreds of millions of species in the past, and one time on Earth has intelligence arisen to the point where we can build a radio telescope, which is the definition of intelligence to a radio astronomer. One time out of hundreds of millions of possibilities. That's an astronomically small number of intelligences that have risen, just one. At last tally, there are several hundred billion stars in the Milky Way galaxy and perhaps 100 billion galaxies in the universe. Yet according to your book, we are just cold, dark and alone. No, we are not alone. We are lonely. There's a big difference between being alone and being lonesome. But in this big galaxy of ours, hundreds of billions of stars, surely Earth is repeated many places, many times. We got the intelligent organisms on this planet after 500 million years of animal life. Now, that doesn't say you couldn't get it sooner at other places, but you still need long periods of time. And to me, that is the major argument against there being intelligent civilizations. We are on a planet that's very safe, a planet that has not been repeatedly bombarded by the thing that killed the dinosaurs, asteroids. How many other planets are going to have such long periods of time? Not many, I think, he says. But suppose life is common in our galaxy. We are now asking of all the planets with life. Isn't intelligence surely going to show up? I still think it's a question of time, Neil. I agree with you. I think life is pervasive in the galaxy. I think that the way the Earth has extremophiles, organisms that thrive in extreme hot or cold habitats, the fact that we can have life, the fact that we can have life living in so many bad environments suggests that you can have life in really nasty places, but it takes time to evolve into a T-Rex or an Allosaurus. However, it takes a long period of time. Now our planet has had a very low record of large asteroid impacts. Jupiter is the major reason for that. One of the great studies of the 20th century showed that if we didn't have a Jupiter, the impact rate on Earth would be 100,000 times higher than it is. As you know, Jupiter sucks in wayward asteroids and comets like a massive vacuum cleaner. This has left Earth free to enjoy the long period of relative calm and stability that has encouraged the evolution of intelligence, Ward argues. Location is everything. It's not hard for me to imagine a solar system that forms when the vacuuming up of the debris in the early phases happened more efficiently than here. For you to base a whole idea about the likelihood of intelligence in the galaxy on the fact that we had some extra bombardment seems kind of thin. No, that's only a piece of the puzzle. But let's stay on that one. Oort cloud is the name of the big bunch of comets. Oort cloud is the name of the big bunch of comets around us. There are many studies suggesting that Oort clouds will be bigger and denser the closer you get to the center of the galaxy. So it could be that we are in a section of the galaxy, real estate wise, that's great for life, and that as you head and that as you head more centrally, where there's more and more stars that form, it gets worse. You know the nature of galaxies, the nature of galaxy centers, they are very dangerous places. There are nasty places, and it's not just asteroids, it's gamma ray bursts, it's supernova, you've got black holes, you've got energetics, you've got sterilization events, so the centers of galaxies aren't going to work, and perhaps half the stars in the galaxy are in the center. So now we have to move off to the suburbs where things start getting spread out. If we go too far out, we run out of the heavy elements necessary to make a habitable planet. I think life is almost everywhere in the universe. But you are asking about intelligent life, and that's a whole different ball game, Peter Ward says. So we've got a portion of the galaxy that is no good, and another portion that is no good. We are looking at narrow real estate areas. How narrow that is debatable. But this debate we are having wouldn't have taken place 10 years ago. We've new information just coming in that seems to narrow in the areas where habitability can take place. Enter geologist. Alright, so you are an intelligent pessimist, but clearly people who professionally look for intelligence in the galaxy, the SETI people, don't share that pessimism. What gives them the confidence that you don't have? He says they are not geologists. I think what astronomers pardon. I think he says they are not geologists. I think what astronomers have missed is the record of our own planet. Geology tells us a couple of very important things. First of all, you need a long period of temperature stability. That's a geological phenomenon. A very finite set of conditions on this planet has allowed us to have liquid water for 4 billion years. We never went above 100 centigrades. We never went below 0 centigrade degrees. For long periods of time. That for 4 billion years is a rare thing, I think, he says. Secondly, the impact rate is also something that causes species to go extinct. 65 million years ago, millions of dinosaurs were suddenly wiped out by an impact. Yeah, but that same incident enabled mammals to become something more ambitious than a tree shrew, he says. Sure, maybe that was an instigator towards intelligence, but you just said it was bad for intelligence. Well, what if such a cataclysmic event happens 100 times, 1,000 times, or 10,000 times, and you are looking at things being knocked out? It took 65 billion years after the knockout to get to the level of intelligence that we have. But as a geologist, is it possible that you are a little close to the problem? You see, Earth in such detail as a planet that sustains intelligent life, that it's inconceivable to you how many different kinds of planets could give you intelligence. You are kind of stuck in a geological paradigm. Maybe it's as much a handcuff as a liberator of ideas. But you astronomers never even considered it. No, we didn't, he says. You've been so far out in space. I never heard them. I know, says, you've been so far out in space. I never heard the term plate tectonics ever used. It's not even in your lexicon. And this is where I think a whole new view comes from biologists and geologists and paleontologists to add to the great work you astronomers are doing. It's not simply a function of how many planets are out there. There is an enormous amount of new information coming from planetary geologists. We know so much more now about how planets form and how habitable planets work. We have this entire new science called Earth system science that examines how the life systems of Earth continue, the carbon cycle, how we have water, how we have temperature changes, the weather patterns, but all of this in sum brings together Earth as a planet which over long periods of time is able to stay alive. It's like the life of an individual. It's born, it grows, and it's these systems that allow it to maintain life. Animals are rare. I don't hear you explore exotic models for what a solar system or planet can be. For instance, maybe there are planets where the water is frozen on the surface, but deep down there's a place where it's liquid, and wherever it happens to be liquid, life goes to that. That's a great idea, and I agree with you entirely. I think there are so many places in the universe that allow life, that I think that life is almost everywhere in the universe. But you are asking about intelligent life, and that's a whole different ball game. I think that even animals are rare. The lowest animals on this planet, worms or snails or whatever, are far from intelligent. Even they are rare. I think because it takes a long time of a planet to allow them to evolve. He says. It took a long time for Earth to do it. Now, when you say a planet, you just generalize this single case that you know for all possible cases that you could exist in the galaxy. That's kind of bold. It is bold, he says, but I think time is still the constant. You need a certain amount of time for evolution to take things from inorganic to organic, from organic to a cell that combines with another cell to eventually intelligence. You're accusing Earth of being rare, but history is filled with cases of people asserting that our place in the cosmos is rare, and the march of science has continuously demonstrated the opposite of that. So here you are now making cogent arguments, but I see you as one in a long series of people who have come before you trying to claim that we are the product of something special. So what makes you the only one in that history of scientists who's correct? Luckily, it's not just me. I am really cutting short a lot of my colleagues. He says, luckily, it's not just me. I'm really cutting short a lot of my colleagues. This has not been just my work, of course. He says, when I look at the variation in the kinds of planets there might be, it's not hard for me to imagine that you could have a planet where all the conditions of that planet promote intelligence, rather than here on Earth, where it's a kind of a special case or a peculiar branch that happened to eke it out of the variation in the biosphere. It might be that there are planets out there where intelligence is rampant. There might be. It's a big galaxy, I'll give you that. Intelligence is rare, he says. Suppose that as we start looking for planets around stars in the galaxy, we find out that planets are common, which appears to be happening. Does that up your estimates a little bit? No, let me use an analogy. He says, no, let me use an analogy. Everyone's in a while a musical genius rises and great symphonies come out. Every once in a while a musical genius rises and great symphonies come out. Now, This is 1 in a million, 1 in 10 million, a really rare happenstance. But still it takes a long time, even for a prodigy, a musical genius, to get to the point where he or she can write that symphony. So in practice we are alone because they are not coming to us and we are not going to them, Neil deGrasse Tyson says. Now what happens if you change the rules and all of these kids die at 2 years of age? None gets even to 10 years. Maybe once in a while you got one rare case. You cut down the possibilities to near zero, and our point is it's probably hard for a planet to exist long enough as a habitable planet for animals to arise. A few do, and of those few that do, you then need another long period of time for intelligence to arise. The numbers get so small. And by the way, let's get rid of the word special. Let's get he says let's get rid of the word special. Special denotes that there's some moral force or something. We don't need to think special. All we need to think is numbers, and we talk about rarity. We are asking, in this huge Milky Way, how many intelligent civilizations are there? Carl Sagan estimated 1 million. We know there is one. It could be zero, love. So the number is somewhere between 1 and 1 million. Maybe it's more than 1 million. I think the most important point is, if it's not 1, is it 2? Is it 10? Is it 100? Even if it were 100, there are 500 billion stars. That's pretty rare. As you know, it took 4.5 billion years for intelligence to develop along just one branch of the tree of life, the primate line. But Tyson asks, couldn't planets that offer better conditions for promoting intelligence exist? Being Earth-like, suppose we come to learn that solar systems that look like ours are everywhere. Will that will that up your confidence in finding intelligent life?
Amelia would like to know if I could change anything.
Suppose we come to learn that solar systems that look like ours are everywhere. Will that up your confidence in finding intelligent life? Let's examine the concept of an Earth-like planet. This is the most commonly used phrase. Earth-like planet. Well, Earth-like planet is a moment in time. Earth-like planet is Earth as we know it now. If we went back 4 billion years, our planet would be the most hostile looking place you can imagine. It wouldn't be an Earth-like planet. An Earth-like planet is not only geography, it is time. Because planets start as uninhabitable. They become habitable if they are lucky, and they go uninhabitable again. So we are looking again not just at the number out there, it's where they are in the whole time frame of things. In principle then, Mars might have had its time in the sun as an Earth-like planet, when now it's clearly completely hostile to life as we know it, as is Venus. Mars is one of the best examples. Mars probably had water to begin with. Mars surely had early plate tectonics. It had everything necessary for life as we know. In principle then, Mars might have had its time in the sun as an Earth-like planet, when now it's clearly completely hostile to life as we know it, as is Venus. Mars is one of the best examples. Mars probably had water to begin with. Mars surely had early plate tectonics. It had everything necessary for life as we know it, and it only lasted maybe 100 million years or less. Where are the intelligent Martians? They never had a chance. Mars maybe had bacteria and then they died out. I think that's the fate of most planets. Mars' fate is the fate of most Earth-like planets. They don't stay Earth-like very long. They die. If you look at when the dinosaurs went extinct 65 million years ago, out of the 4.5 billion years of Earth, that's not very long, yet is sorry. If you look at when the dinosaurs went extinct, if you look at when the dinosaurs went extinct 65 million years ago, out of the 4.5 billion years of Earth, that's not very long. Yet, in that period of time, intelligence as we know it rose up from whoever existed. Animals went from tree shrews to modern humans. But that's not right, Neil says. That's not right, Neil, he says, because you needed all the time that came before. You have to go all the way back to trilobites and flatworms and everything that came before. You just can't start 65 billion years ago and say we're starting from scratch. We are starting from scratch. You just can't start 65 million years ago and say we are starting from scratch. It is 65 million years to intelligence. What about all that genomic construction that was necessary over the hundreds of millions of years prior? The right recipe. What then is your recipe for a planet that will breed intelligence? Just go down the list. What do you need? Let me answer by saying, what do I need to breed animals, which is our complex life? Intelligence is a whole other ballgame. Obviously, you have to have a sun that's large enough to give a constant amount of energy over time, and yet a sun that is not so large that it burns out quickly. As you know, Our sun is getting brighter, brighter, brighter. A billion years from now, this planet will no longer be habitable for intelligence because our sun will be too bright. So you have to have something that gives you enough time. No, the small stars, of course, let you go for a long time, 20 or 30 billion years. They live longer. They live longer, but as a planet you would have to be so close to them as to become totally locked, just like our moon, the same phase all the time. Well, you've got one side that's really hot and one side that's really cold. That's not going to work either. Well, then everyone lives along the border between the hot and the cold. I don't think so, he says. People are studying that right now. It doesn't seem to be an option. Now, you know and I know that 3/4 of the stars, 3/5 of the stars in this galaxy, correct me if I am wrong, are those tiny stars. Yeah, the majority, he says. So we've just thrown out more than half of all the stars in the galaxy. The big stars, they are gone. The double stars, they are probably gone because the orbits of the planets get so irregular that you start throwing things around. You throw out all those. Now you are really cutting down the number. The centers of galaxies, they are gone. So we have really cut down to maybe 10% of the stars in the galaxy. That's still a huge number. So let's think about planets. I stand by the great Enrico Fermi's question, where are they? Peter Ward says. Earth maintains constant temperature because of the strangest circumstances. It turns out that plate tectonics causes carbon to recirculate in such a way that when we get too hot, we pull greenhouse gases out of the atmosphere and turn them into coral reefs. When we get too cold, the coral reefs dies. Volcanoes put more carbon dioxide in the atmosphere. This only works because of plate tectonics. One of the most interesting aspects of studying the geology of planets is asking the question, how common will plate tectonics be? We don't know, but all indications are it's rare. It takes very specific geological conditions to allow it. As you may all know, coral reefs and all other living things on Earth owe their existence to plate tectonics, which may be rare on Earth planets, Ward says. Where are they? Getting back to intelligence. If you are not alone, you are telling me there is other intelligence out there in the cosmos. I cannot believe that we are the single intelligence in the universe. What I can believe is maybe there is one per galaxy. We are really scattered, lonesome, very lonesome. So what you are saying is, if we are going to try to find other intelligence, good luck, he says. We need to broaden that search to go well beyond the Milky Way to rest of the galaxies in the cosmos. There are probably so few intelligences in our galaxy that to find any of them could be a remote chance. So we should just give up? I don't think we should give up. SETI is an interesting, intelligent, intellectual in the why not continue it? I just don't think they'll ever find anything, or if they do, the separation is so great you could never signal back on fourth, says. So in practice we are alone because they are not coming to us and we are not going to them. I stand by the great physicist Enrico Fermi's question. I stand by the great physicist Enrico Fermi's question. Where are they? If there were so many, if we would have had a signal, we would have seen somebody. There would have been a visitation. That's not happened, he says. Thanks for watching, thanks for listening.